Hi, this is Albert Nixon, Assistant Professor, Department of Chemistry, St.Joseph's College of Arts and Science, Autonomous, Cuddalore. In this video, we are going to discuss about periodic properties and its classifications. This is a periodic table. It consists of S black, B black, and D black, and F black classification of element. With the discovery of a large number of elements, it became difficult to study the element individually. So classification of element was done to make the study easier. Mendeleev's periodic table. Mendeleev's periodic table is based upon Mendeleev's periodic law, which states the physical and chemical properties of the elements are a periodic function of their atomic masses. At the time of Mendeleev's, only 63 elements were known. This periodic table is divided into 7 horizontal rows are called periods and 8 vertical columns are called groups. Zero group was added later on in the modified Mendeleev periodic table. Some importance of Mendeleev's periodic table: systematic study of elements, prediction of new elements and their properties. He left space for the elements yet to be discovered. Atomic mass corrections of doubtful elements on the basis of their expected position and properties. Defect in Mendeleev's periodic table. The first defect is position of hydrogen. Hydrogen has been placed in group 1A. It is alkali metals, but it also resembles with the halogen of group 7A. Thus, its position in the Mendeleev periodic table is controversial. Second one is position of isotopes. As Mendeleev's classification is based on atomic weight, isotope would have to be placed in different positions due to their different atomic weights. For example, 1H1, proton, neutron and deuterium would occupy the different positions. Then third one is anomalous position of some elements. Without any proper justification, in some cases the elements with higher atomic masses precedes the element with lower atomic masses. For example, aluminum atomic weight is 39.9, precedes potassium atomic weight is 39.1, and similarly cobalt atomic weight is 58.9 has been placed ahead of nickel. Nickel atomic weight is 58.7. So it is a major defect in Mendeleev periodic table. Then position of lanthanides and actinides. Lanthanides and actinides were not placed in the main periodic table. The next one is modern periodic table in the year of 1913. Moseley modified Mendeleev's periodic law. He started physical and chemical properties of elements are the periodic function of their atomic numbers. It is known as modern periodic law and considered as the basis of modern periodic table. When the elements were arranged in increasing order of atomic numbers, it was observed that the properties of element were repeated after certain regular intervals to 8, 18, 18, 32. These numbers are called magic numbers. Structural features of long periodic table. Long periodic table is called Bohr periodic table. There are 18 groups and 7 periods in this periodic table. The horizontal rows are called periods. The first periods contains 2 elements, hydrogen and helium. It's the shortest periods. The second one is lithium to neon. So lithium atomic number is 3 and the neon atomic number is 10. Then third period is sodium to argon. It contains each elements. These are also short periods. The fourth one is potassium to krypton, and fifth one is rubidium to xenon. These are long periods, so that contain 18 elements each in fourth and fifth. The sixth period is cesium to radon, consists of 32 elements and is the longest period. The seventh one is starting with francium, incomplete, consists of 19 elements. S black elements. Elements in which the last electron enter in the s orbital of their respective outermost shells are called S black elements. S subshell has only one orbitals which can accommodate only 2 electrons. Therefore, there are only 2 groups in S black elements. Elements of group 1 like alkali metals, and group 2 is alkaline earth metals. Hydrogen has only one electron and this enters first 1s orbitals. The rest of the elements, that is lithium, sodium, potassium, rubidium, cesium and francium, receive the last electron in 2s, 3s, 4s, 5s, 6s and 7s respectively. Helium and the elements of group 2, that is alkaline earth metals, beryllium, magnesium, calcium, strontium, barium and radium, the last electron in these elements also enter in the s orbital, that is 1s2, 2s2, 3s2, 4s2, 6s2, 7s2 and 7s2, right? These elements also belongs to S block elements. There are 14 S block elements in the periodic table. So some characteristics of S block elements: they are soft metal with low melting and boiling points. They have low ionization enthalpy and are highly electropositive in nature. They lose the electron readily to +1 to +2. They are very reactive metals. The metallic character and reactivity increases as we move down the group. The compounds of S block elements, with the exception of beryllium, are predominantly ionic. Most of the metal of this S block is characteristics of color to flame. They are strong reducing agent. All are good conductors of heat and electricity. Next, B block elements. Elements in which the last electron enter any one of the 3p orbitals of their respective outermost shell are called B block elements. As p subshell has 3 degenerate p orbitals, each one of which can accommodate 2 electrons. So totally 6 group in B block elements, like 13th group, 14th group, 15th group and 16th, 17th, 18th group. The atoms of elements belonging to these groups receive the last electron in 2p and 3p, 4p, 5p and 6p orbitals. The elements of group 13, 14, 15, 16, 17, 18, in which p orbitals are being progressively filled in the p block elements. They are totally 36 p block elements in the periodic table. Group 18 are called noble gases except helium. All the elements have closed shell ns and np, so there are filled configurations. That's why it is otherwise called inert gases. The elements of group 17 are called halogens, while those of group 16 are called chalcogens. The elements have high negative electron gain enthalpy and hence ready to add 1 or 2 electron to attain the stable noble gas configurations. The elements of S and P block are called representative or main group elements. Characteristics of B block elements: B block elements include both metals and non-metals, but the number of non-metals much higher than that of metals. Their ionization enthalpy are relatively higher as compared to S block elements. They are mostly from covalent compounds. Some of them show more than one oxidation states in their compounds. For example, you take boron family. So boron, aluminum, gallium, indium, and thallium. So boron is exhibiting plus 3 oxidation states, and to moving down the group, thallium is exhibiting 2 oxidation states, plus 1 and plus 3. According to inert pair effect, plus 1 is more stable than plus 3. Next, T block elements. Elements in which the last electron enter any one of the 5d orbitals of their respective penultimate shells are called D block elements. Since d subshells has 5d orbitals, each one can accommodate 2 electrons. So totally 10 vertical columns comprising 10 groups, like 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. General characteristics of D block elements. They are hard, malleable and ductile, and also having high melting and boiling points. They are good conductors of heat and electricity. Their ionization enthalpy between S and B block elements. They show variable oxidation states. It is one of the extensive property of D block elements. They form both ionic and covalent bond. Their compounds are generally colored and paramagnetic in nature. So paramagnetic is nothing but the presence of odd electron. Most of the transition metals such as vanadium, chromium, manganese, iron, cobalt, nickel, copper, their compounds are used as a catalyst. So these are widely used as catalyst. Most of the transition elements forms alloy. Zinc, cadmium and mercury, which have the ns electronic configurations, do not show most of the properties of transition elements. Then finally, F block elements. These elements in which differentiating electrons enters at a n-2 f orbital, so called F block elements. These elements are also called inner transition elements because they form a transition series within the transition elements. The electronic configurations of lanthanide is xenon of 4f 1 to 14, 5d1 and 6s2, and actinide series is radon 5f 0 to 14, 60 0 to 2 and 7s2. So lanthanide series elements following lanthanum, lanthanum at atomic number 57 to lutetium is an last element of the lanthanide series, whereas 4f orbital are gradually filled are known as lanthanide series. The actinide series is actinides, actinum 89 and end with lawrencium at 103. The 5s orbital are gradually filled as known as actinide series. Some general characteristics of F block elements. They are heavy metals. They have high melting and boiling point. They show variable oxidation states, especially plus 2, plus 3, plus 4, up to plus 7. Their compounds are generally colored. They have high tendency to form complexes. Most of the elements of the actinide series are radioactive. That's why it is called radioactive elements. Some general properties of periodic table. So we know the size, ionization energy, electron affinity, electronegativity, then acidity, basicity. Right? These are the some general properties of periodic table. Here I am shown on simplest representations the periodic trends. When moving left to right, size decreases. To moving down the group, size increases. Ionization energy under electron negativity moving left to right increases, moving down the group decreases, and metallic character moving down the group decreases, and non-metallic character moving left to right is increases. Thank you for your patient listening. Thank you.